Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Alene, H to C is equal to C is equal to CH2, is accumulated diene. In alene, the two CH2 groups at either end are perpendicular to each other due to the geometry of the cumulated double bonds. The central carbon is sp hybridized, and the two sets of pi bonds are orthogonal. Moving on to the next step. Understand the geometry of alene. The left CH2 plane and the right CH2 plane are perpendicular, 90 degrees, to each other. So if the left CH2 has its H atoms in the plane of the paper, one wedge, one dash means actually both in plane for a CH2 group on sp2 carbon. Let me reconsider. In alene, the left carbon's HH axis is perpendicular to the right carbon's HH axis. Moving on to the next step. Identify L1 and L2 from the diagram. L1 spans from the upper left H to the upper right H, a long diagonal distance across the entire molecule. L2 spans from the lower left H to the lower right H, another diagonal, but the two CH2 planes are perpendicular, so this is a shorter 3D distance. And for the final step. In alene, the C is equal to C is equal to C backbone is linear. The two terminal carbons are separated by 2 times, C is equal to C bond length, 2 times 1.31A is equal to 2.62A. The left H atoms lie in one plane, say the XZ plane, and the right H atoms lie in the perpendicular plane, the YZ plane. L1 is drawn as spanning H, upper left, to H, upper right since the planes are perpendicular. One H is in one plane and the other H is in the perpendicular plane. L2 spans H, lower left to H, lower right, similarly. More carefully, L1 as drawn in the image is the distance between one H on the left carbon and one H on the right carbon that are both projected upward, but because the planes are perpendicular, the actual 3D arrangement means L1, top H to top H, in the plane of paper across the full molecule, is longer than L2, bottom H to bottom H, which are displaced out of plane relative to each other. The arrow for L1 spans the full width of the molecule at the top, while L2 spans a shorter diagonal at the bottom. L1 is the longer distance across the full molecular width in plane projection, and L2 is shorter. The H atoms on the bottom are on carbons whose HH axes are perpendicular, making the bottom-to-bottom H distance shorter in 3D. Therefore L1 L2. Why other options fail? A. L1 is equal to L2 would only be true if the geometry were symmetric in the same plane, which it is not due to perpendicular CH2 planes. C. L1 L2 is the reverse of the correct answer. D. L2 is equal to L1 is numerically incorrect. Therefore, the correct answer is B. Therefore, the correct answer is option B.